Good afternoon, everybody. Welcome to exciting Monday afternoon, the first Monday of October of Chem 170 with your host, me, Dr. White. Now, over the weekend, I officially started fall. How do you know I officially started fall? I moved my long sleeve shirts to the front of my closet, and my short sleeve shirts to the back. And that's the official start of fall and winter, which it has. If you've been out early morning, it's cold out there. But anyways, let's talk about organic chemistry. All right, important announcements. First of all, I believe it's a week from this Wednesday, we'll have test number 2. Today I better finish all the material that will be on test number 2 we'll have done, which I always try and finish up about a week before, so you have plenty of time to practice and study. Now, not to scare you, but I will. Test number 2, historically, and I've been teaching Chem 170 a long time now, is usually the lowest average of the 4 tests, but it doesn't have to be. I've had classes where it isn't, but the majority it is. Why? Well, there's a lot of hard stuff on there. Relax. If you do the practice problems on your own before the test and get them right, you'll do good on test number 2, but you got to keep up. All right, that's the first thing I want to talk about. Second thing I want to talk about, I was looking at the schedule and everything. I said, oh no, we're a week ahead in the lab. You notice I'm off by a week. And how do we get ahead? Well, the second week I haven't gone back and look at the videos, but I should. I was just being lazy, but I'm pretty sure it's true. Second week where I had in the syllabus no lab, we did a lab. And sometimes that happens. But anyways, because the reason why it happens online is if we were face to face, we do lab check-in and a safety video. We're not face to face, so I don't have lab check-in or safety video. But anyways, what that means is this Wednesday, we're not going to do a lab. I'll still have lecture, but to get in sync with my syllabus, I like the fancy visuals here. To get in sync with the syllabus, we won't be doing a lab, but this will give you time. If you haven't handed in your labs, hand it in. And with that, it's time for me to get going and do some new stuff and old stuff. All right, thumbs up, people. Do you see reversing of the hemiacetal, hemiketal? All right, I started this last Wednesday. Let's go back to it. Let me get my tablet oriented correctly. All right, the reaction, and this is the third of 4 reactions that I said, relax, are somewhat challenging at first. And here, can you see it okay, everybody? Okay. This is a hemiacetal or hemiketal. When our double prime is hydrogen, it's a hemiacetal, and I'll never ask this on a test, but other classes you might want to know this. And if I take acid and water, H plus is how we in general say an acid. And you should have known from your general chemistry, acids can be like sulfuric acid, hydrochloric acid, and the one really we should be using, but I'm using in general, is HCl, because one of the miracles of life in my mind is my stomach and your stomach has cells that make hydrochloric acid, H plus. Now, look for what's different. what's not carbon, what's not hydrogen, should have gotten your attention like that. And we have a carbon with two oxygens. One of them has an R group. And that's a giveaway that when you do acid hydrolysis of a hemiacetal or hemiketal, you get back the ketone or aldehyde plus the alcohol you would have used to make this compound. And therefore, if I do the following, what do we see that's different? Two oxygens on the same carbon. One has a hydrogen, one has R groups. And on that carbon, did I tell you the closer it gets to Halloween, the worse my hydrogens look? Nah, I don't think you'll buy that. But anyways, what do we have here? I'll call that our prime carbon hydroxyl group, oxygen, R, and on that same carbon, I could have our double prime or hydrogen. In this case, it's a hydrogen. And the general reaction when you're reacting with acid and water, keep your eye on the carbon with the two oxygens, and I am. And what's attached to that, our double prime or hydrogen or R prime is still attached, and that same carbon is now double bond to oxygen. And this R group here on the oxygen becomes this alcohol. Now, the carbon in R with the oxygen will be the same carbon in R with the oxygen from the hydroxyl group. So let's go back up to our reaction, and I'll call this our double prime, this R prime, and on the oxygen, that's R. I'll keep my eye on this carbon, and I'll draw that first. What's attached to it? R prime, hydrogen, R double prime, or R prime and R double prime, oops, methyl, and this will be double bonded to oxygen. Now, my ethyl group here, think about it, 6 months ago, how many of you would know what an ethyl group is? Just think how far you've come. Doesn't that feel good? You're learning a lot, and you should be proud of yourself. I am. And my R group will be this alcohol, and here's what you get. So keep your eye on the carbon with the two oxygens. Follow it, becomes this carbonyl. Remember, carbonyl, carbon, oxygen, double bond. Carbon, double bond to oxygen. And I'll hold off, so I see somebody's writing it. Did I tell you I had the fastest mouse wheel finger either side of Miss? Yeah, I think once, twice, or a million times. And I do. I gotta stop, don't move yet. All right. And it's your turn to have some fun. Don't you like it that Dr. White shares the fun? You can say no, it's permitted. You can say maybe too. So far, it's still a free country. Oh, by the way, on a serious note, everybody have this copied down? Let me do a personal thing. Coming up in about 4 weeks is the national election. Brave men and women have died so we can vote. I have never missed an election in my life yet, other than a minor local city election. I was in Germany and I forgot to get a ballot, mail-in ballot. And that's the only one time in all the years I've been voting. And I've been voting since many decades. Brave men and women have died so you can vote. Everybody's vote counts. Just look what's happening now in the Supreme Court, because a lot of people didn't vote in the last election. Maybe you like it, maybe you don't, but that's the cause. Register. In Illinois, it's easy to register and vote. In Illinois, it's easy to vote. You register, you can also get a mail-in vote, or you can vote early. By the way, since the pandemic, I've been using the mail-in vote, and it works. All right, back to our problem. All right, your turn. Have some fun. I see one person is done. Thank you, but I'll be patient. Hopefully you will too, to let everybody have time to do it. No, 2 people are done. I don't know, I've mentioned this once, twice, or a million times. If we were face to face, I'd say, when you're done, look up and smile. And some students do that, but I can see from standing in front of the class when everybody is done, like now. So it's my turn. Look at for what's different, what's not carbon, what's not hydrogen, should get your attention like that. And ooh, we've got a carbon with 2 oxygens attached to it. That's rare. There's only 2 places you'll see that. This is one. In a little while, I'll talk about the other. So that carbon has a hydroxyl group, an oxygen. On that oxygen, I have carbons I'll call R. To the same carbon, I have carbons here and here. I can call R prime, R double prime. R double prime could have been hydrogen, but in this case, it's not. And when I react it with acid and water, remember H plus is acid, keep your eye on this carbon, what's attached to it, R prime or hydrogen, and our double prime, or our double prime and our double prime or hydrogen. This carbon is now double bonded to an oxygen, a carbonyl. And then this R group right here becomes this alcohol. And if we look here, I'll call that R prime, that R double prime. They're the same, but I'll still do that. And then this one I'll call R. So I'll keep my eye on that carbon. Oh, by the way, you don't have to put a dot in there when you take the test. But what's attached to it? R prime, 2 carbons. Why? Because do you break carbon-carbon single bonds? No. And down here, 2 carbons. And this is double bond to an oxygen. And then I still have the alcohol. Here's my R group, methyl. And there you go. And that's how you do it. And like I mentioned, this and the next reaction is how your stomach breaks down carbohydrates. And later in the semester, I'll show you specifically how it breaks down carbohydrates using this and the next reaction I'm going to show you. Any questions? All right, everybody got a copy down? Okay, well, in that case, let's try another one. And here's another one for you to try. Give the organic product or products 3 points each. You know something, Dr. White's been very lazy. So I should do this. And sometime in the future, on some file I send to you, you may see something like this. Three points each. Give the organic product or products 4. And here's one. Hey, your turn. Almost everybody's done, so I'll be patient. On a personal note, I'm sleeping a lot better now because I've gotten back to my soybeans. I'll teach you later in the semester why that's important, but it helps you sleep better. Plus, I've gotten back to seriously pumping iron. For those who don't know what that word means, it means I've been working out weights again. I mean, serious, big time. And at my age, that's pretty good. Most people my age are sort of in a nursing home by now. I don't even want to think about that. All right, time for me to get to work. And the question is, what's the organic product or products sort of following? Oh, one thing, bad Dr. White. On a test, I might do this, which tells you if you see a plus sign, there are 2 products. I've been forgetting to do that, but on a test, I don't. So we look for what's different, what's not carbon, what's not hydrogen. Ooh, 2 oxygens here. And so this carbon, one's a hydroxyl group, one's an oxygen with carbons on it. And attached to this carbon, carbons here and here. Now our double prime could be hydrogen. And because we're in the ring, these carbons, oh, it looks like a smiley face. Rings do smile. No, never mind. These are connected together. And for this general reaction, keep your eye on the carbon with the 2 oxygens. What's attached to that, our double prime or hydrogen and our prime are still attached. That will be double bond to carbon. Then the R group here on this oxygen will be this alcohol. So if I look at this carbon right here, what's attached to it, these carbons and these carbons, meaning a ring, will still be attached to this carbon, which is this carbon. And the general reaction tells me that carbon will be double bonded to a oxygen, which means we have a ketone. And then the carbons on this oxygen, this is R, will form this alcohol. And that's how you do it. And it's time to move on. So we shall. Now, this was reacting acid and water, or water and acid, with a hemiacetal. Now, you can also reverse, or I should have really put down acid hydrolysis of an acetal or ketal. And here's the way I have it here. Think of this being a carbon here. My software does that, and a carbon there. But let me rewrite this. And actually, this is the first step how your stomach breaks down carbohydrates. Now, if you had the good stuff, potatoes, rice, potato chips, French fries, stuff I don't need. But anyways, keep your eye on this carbon. What's attached to that? Our prime or hydrogen, double prime or hydrogen, and our prime is still there. And you get a carbonyl, carbon double bond oxygen from that carbon. Now, these R groups here become this alcohol. Now, let's go back and look at the problem. What does the problem say? By the way, say hello, whoever you're saying hello to, Ignacio. Say hello from Dr. White. All right, if you look at the problem, what does it say? Give the organic product or products. It does not say balance the chemical equation. So right now, I'm done with this, General. Now, a couple of years ago, I had these two twin sisters in my, actually it was Chem 1212, which is same as Chem 170 here, and they got really upset if I didn't balance things. So it's not fun to have upset twins. One student's enough, twins, no. So I started doing this to make them happy, which made me happy. If you want to put a 2 here to balance it, you can. You don't have to. So let's take a look at this reaction. If we look at the following reaction, the question would be, what's the organic product or products for the following? And the first thing you do is look at a molecule and look for what's different. What's not carbon, what's not hydrogen, should get your attention like, I had to work that in like that. And, oh, look, we've got an oxygen here, an oxygen there to the same carbon. And this is the only other place, the one I just showed you, and this. And on each one of those oxygens, they're carbons. And on that same carbon, I have carbons here, I'll call R prime, and I could have more carbons, R double prime, or a hydrogen. In this case, it is a hydrogen. And when you react it with acid and water, and I keep on forgetting today, I should have put a plus there to tell you there are two products. That's my special gift for you on test number 2. And keep your eye on this carbon with the 2 oxygens. What's attached to that carbon, R prime, R double prime, or hydrogen is still attached. And that carbon will be double bond to oxygen. And then these groups on the oxygen R become an alcohol. Now, if you want, let's see how small I can write 2. You can put the 2 there. You don't have to. So let's take a look at this. This is our double prime to this carbon. This is R prime. And on the oxygens, they're the same R. Oops. So I'm going to keep my eye on that carbon. What's attached to it are two carbons and a hydrogen. Our double prime are still there. And my general reaction shows me this carbon will now be double bond to oxygen. And then if I look down here, the R groups on the oxygen become this alcohol. The carbon with the oxygen here will be the carbon with the hydroxyl group. Well, in this case, two carbons, so now technically I'm done, but if you want, you could put a 2 there. I put it in quotes saying, meaning you don't need it. And that's how you do it. If you go back and look at your notes, what we're undoing, reversing, I take this aldehyde and two alcohols, acid catalyst, no water, we'll get back to this. And to undo it, acid and water. And this is the first step, which is why we drink water to keep in our stomach, how to break down carbohydrates. You know, like all the good stuff, I really need like a hole in my head. Why am I thinking of Lay's sour cream and onion potato chips? Because they're dangerous. If I open a big bag in my house, I don't know why, but they seem to evaporate like that. I don't think a big bag lasts more than an hour in my house, even less, especially doing a football or soccer game. Boy, they just disappear. So I only buy them a couple times a year. All right. I'm going to share the fun. Wow, that's a big, scary molecule. Not really. Let's see if you're up to it. Remember this and the previous three reactions I went over. I will never, ever put I forget to do this today. Today's forget the plus sign Monday. But anyways, I will never put a synthesis problem for this on a test. And don't forget, hand in your lab on Wednesday. That's due on Wednesday, please. I've graded last week's lab, and the other one I forgot to post. And either today or tomorrow, I'll post those scores in D2L. Ooh, I gave you a good one to work on. I don't think I've ever given you a bad one to work on. Remember, look at the general reaction. And we'll have to wait for everybody to finish. Please be patient. All right, my turn. See, I even let Dr. White have some fun. And remember, I warned you this chapter working with ketones and aldehydes and their derivatives, I'm having a lot of fun. All right, look for what's different, what's not carbon, what's not hydrogen. I'm going to go Technicolor. Oh, we've got an oxygen here and here, and it's got carbons on it. They're the same. So this I'm going to call my R group. And to that carbon with the two oxygens, there are carbons here and here. So I'll call that R prime, R double prime. This could have been hydrogen. It's not, but it could have been. And we add acid and water. What do we get back? Keep your eye on this carbon with the two oxygens. It will now be double bond to oxygen. What's attached directly to it, carbon or hydrogen wise, our double prime or hydrogen or and our prime will still be there. Because do we break carbon-carbon single bonds? No. Anybody having nightmares hearing me say that yet? Uh-oh, I'm getting into your brain. I didn't warn you how dangerous I am. I do that. And we're not done. This R group becomes this alcohol. Now, for those who must, you can put a 2 there. Can I make that any smaller? I'll try. All right, let's go back. This is my R prime. This is my R double prime. It's attached to that carbon. I'll write that carbon first. That's this carbon. It's going to be double bond to oxygen. R prime methyl. R double prime and propyl. Remember, there are 4 bonds to carbon. Always keep that in mind. I keep that in my mind too. Oh, that was awful. Sorry. And now we have this alcohol. From here, my R group is 3 carbons. Now here, which carbon is this oxygen bonded to? And the answer is the end one. Therefore, the end one, doesn't matter which end, I always write mine on the right, you can do the left too, would be the carbon with the hydroxyl group. Now give everybody a little time, check your answer. All right, everybody check their answer. All right, let's try another one of these. Message to Dr. White, message to Dr. White, don't forget the plus sign. I didn't. And it's your turn now. What would be the product or products, organic product or products for the following reaction? And the plus sign tells you there are 2. Boy, that is an interesting looking molecule. Now you know I'm an organic chemist. Aren't you proud of yourselves, all of you? You can do this after a little practice. Hopefully it's not too painful either. Hopefully it's not painful at all. How many of you heard bad things before you started this class about organic chemistry? Do you hear how bad it is and tough? Well, it's a lot of work, but it's not impossible. All right, anybody need more time? Well, I guess it's my turn now. All right, let's look at this reaction. What's different? What's not carbon? What's not hydrogen? Ooh, oxygen here, oxygen here. And if we look at that, there's two oxygens to the same carbon. And each one has carbons on it. And to that same carbon, I have this ring, but this is carbon hydrogens. I'll call that R prime. And I have a hydrogen. Well, this could have been R double prime, but in this case, it's a hydrogen. And this is an acetal or ketal. In our case, it's an acetal because R double prime is hydrogen. And when you react that with acid and water, what do you get? Keep your eye on the carbon with the two oxygens. That's double bond to oxygen, carbonyl. And my R prime and R double prime or hydrogen are still bonded to that. Because you know you don't break carbon-carbon single bonds. No. And the R group here on the oxygen becomes this alcohol. For those who must, I wonder if I can write a 2 any smaller. You put the 2 there. I wouldn't because I'm a lazy organic chemist. All right, let's go back to our original reaction. I'll call this R prime, this R double prime, and these R. Now, if I go to my general reaction, this carbon, which is this carbon, will be double bond to oxygen. What's attached to it, R prime, double prime, which is hydrogen, and R prime, which is a 5-membered ring. That would be our aldehyde. And then on the oxygens up here, both our groups are methyl. So I'm done. Now, if you want to put a 2 there, you can't. You don't have to. And that's how you do it. Any questions on this? Remember, this reaction, like the previous 3, I will not put on a test or the final exam. How do I know that? Because I write my own test and exam, final exam, and I won't. All right, it's time to move on, but we'll come back to this again because it's a little complex. All right, everybody see the Grignard reaction on your? All right, this and the next reaction were invented or discovered, either way, it's the same thing, by one of the great organic chemists. That's the great organic chemist, Victor Grignard, Dr. Grignard. Everybody see Victor Grignard Wikipedia on your screen? Thank you. All right, I'm going to minimize this so everybody can see it. Yeah, I think I can get away with not minimizing it. Now, this is Victor Grignard. What a great mustache. But anyways, he won the Nobel Prize for what I'm going to teach you. One is called the Grignard Reagent, and the other is the Grignard Reaction, named after him. And does it say when he won his Nobel Prize? Yep, 1912, which is a while ago, but this is a great reaction. And what makes it great, and I've mentioned this before, but I need to mention it again, and that is whenever you can make a carbon-carbon single bond, that's something very special, a very rare reaction. I know personally about 400 to 500 general reactions. I've never sat down and counted them. In this class, relax. I'm only going to teach one time a student a couple of years ago counted them. I think that student got 52 reactions. There are many more I don't even know. Of all the reactions in organic chemistry, there's only about 20, 25 reactions where you can make a carbon-carbon single bond, something very rare, very, very special, and very, very good and useful. And Victor Grignard came up with two of them. I'll be teaching you one today. And later, when we get into another functional group, I'll show you what he also invented. So what's this great discovery Victor Grignard came up with? And the first one is making the Grignard reagent. And the Grignard reagent is reacting an alkyl halide, carbon with a halogen with magnesium metal. Now, I don't show this in this semester, but just about every organic chemical reaction I know of, I think almost all of them, are done in a solvent. And that can be water, or it can be things like an ether, like diethyl ether, or another ether called tetrahydrofuran. And the Grignard is usually run in an ether. And here, I don't have it here, so I better write it. X can be chlorine, bromine, or iodine. And you react the hold on, reboot my jaw. You take an alkyl halide, react it with magnesium metal, and you form the Grignard reagent. And it's such an easy, high yield, fun reaction to do. Now, please watch something important. The R group is bonded to the magnesium, and the halogen is bonded to the magnesium. Common mistake students make is they write the Grignard reagent like that. And this is a carbon bonded to a halogen, which is then bonded to magnesium. No, wrong. It even says it on the screen. No such thing exists. Order is important. Please pay attention. And if we look at the following reaction, the question is 3 points each. Give the organic product or product for the following reaction. And if we look at this, look for what's different. What's not carbon, what's not hydrogen, should get your attention like that. And here, ooh, we have a halogen chlorine on this carbon. I'll do that. Remember, X can be, in our case, it is chlorine. It could be bromine. or it could be iodine. And then you react it with magnesium metal, that's different, and you form the Grignard reagent. Now, the carbon in R with the halogen will be the carbon in R with the magnesium halide bond to it. Do you break carbon-carbon single bonds? No. So I have, this is my R group. Well, I better end up with that. Which carbon has the halogen? This one. And there you go. Oh, not yet. Remember, 4 bonds to carbon. The magnesium chloride counts as 1 bond. Remember, the magnesium is bonded to this carbon, and the chlorine is bonded to the magnesium. And we have made the Grignard reagent. Such a fun, nice reaction. Your turn. Give the organic product or products for the following reaction. 3 points each. Oops, Dr. White made a mistake. Thank goodness I caught it. Now it's not a mistake. So I told you I don't walk on water unless it's frozen. Even then I stay off it, which means I do make mistakes. Oh, looks like everybody's almost done. All right, time for Dr. White to get to work. We looked at this molecule. What's different? What's not carbon? What's not hydrogen? Ooh, an iodine, halogen, alkyl halide, magnesium metal. That's unusual. And remember, X can be chlorine, bromine, or in our case, iodine. And what you form is the Grignard reagent. What's my R group? This. Do you break carbon-carbon single bonds? No. 1, 2, 3, 4 carbons. Which carbon is the halogen bonded to? That's the carbon that the magnesium iodine. And that's what you get, the Grignard reagent. And with that, oh, I went a whole minute over. Let's take a break. 5 minutes. Please come back at, by my clock, 1:56. And I'll see you in 5 minutes. See you in 5. I can get up and stretch. I'm back. I was looking out the weather window in my living room. I see my neighbors across the street, two of them who have young kids, already have their Halloween stuff up. And it made me sad because since we're not face to face, I can't do what I do around Halloween. When I teach face to face, I always bring in candy for my class, whether we actually have it on Halloween or the day before or after. And I do Halloween candy like I do my golden rule of teaching. I have a golden rule of Halloween candy, and that is I always give out candy to people who come by my door and my students of stuff I really like. I don't buy that cheap garbage. I usually get Kit Kats, and students love it. But here, now I can't hand it through the screen. Sorry. All right, we're talking about the Grignard reaction. And the Grignard reaction is where you take an alkyl halide, carbons with a halogen, react it with magnesium to make the Grignard reagent. And this is a reaction I can also ask as a synthesis problem. And the question is, what would I react with magnesium to make that new molecule? Your turn. Am I nice or not? I'm letting you do all the fun stuff. On a serious note, by the way, I used a Grignard reagent in my PhD thesis work. In industry, I didn't use this, but other areas of the chemical industry do use this reagent. But it helped me out a lot in my PhD thesis to make molecules I needed. By the way, synthesis is the fun part, the best part of organic chemistry, but I'm biased because I'm a synthetic organic chemist. And when you're done, you know the drill.
Dr. White.
That's me.
A few weeks ago, you had mentioned Jeffrey Dahmer.
Oh yeah.
And my TV popped up Jeffrey Dahmer, which was kind of weird.
What? Just now or when?
No, a few weeks ago. I just never brought it up. But my
Do.
TV's listening to
Okay.
you.
Spooky.
Yeah.
Wow. The time when I jokingly said, "Is that Jeffrey's father?" And he said, "Yes." Boy, that was bizarre. Every time you talk to him, I wanted to say, "What went wrong with your son?" Luckily I never did, but there was a little voice back here saying, ask, and I fought it off. All right, let's do this. What's different here? What's not carbon? What's not hydrogen? Ooh, magnesium bromide halide on a carbon, and this is the Grignard reagent, where X can be chlorine, bromine, or iodine. In our case, it's bromine. And how do you make the Grignard reagent? Alkyl halide plus magnesium. What's our R group? this right here. The carbon with the Grignard MgX will be the carbon with the halogen. And notice here our halogen is bromine. I have my R group because I know I don't break carbon-carbon single bonds, and I haven't added any carbons here, so it's still going to be a T-butyl group. And the carbon with the magnesium halide will have the magnesium or the halogen. In this case, that's bromine. All right, well, now we've made this reagent. So what? What's so important about that? Well, it's the Grignard reaction. And here's the reaction of the Grignard of a ketone or aldehyde. And one of these R groups could be hydrogen and carbon here and carbon here. Now, before we go over this, let's go over something basic that I want to show you. Let's say we have two reactions. We take A plus B and we make C. Then we take C plus D and we make E. So overall, we start with A and B and eventually we'll make E. Well, organic chemists being lazy, this two-step reaction we write like this a lot of times. A, in the first step, we put above the arrow, which is this, reacts with B. We don't show the intermediate. Then we say the second step we'll put below. I'll take whatever I reacted A and B with, and now reacted with D, and I'll get E. So what I'm showing here in one easy way are these two steps. And we don't indicate what's the intermediate because we reacted further on. Well, we use this for the Grignard. By taking aldehyde or ketone, if our double prime is hydrogen, it's an aldehyde. If it's carbons, it's a ketone. And then, first step, I'll react it with the Grignard, and I'll use our triple prime. Somehow years ago, I started doing that for this reaction. And the second step, I'll add acid and water. Now, all fun happens at the carbonyl carbon. And what happens is this attacks that. Remember, organic chemists are violent, and opens it up. And the second step converts what is made into an alcohol. And first of all, what's attached to this carbonyl carbon is still attached to it. Our prime and our double prime, remember, our double prime could be hydrogen. Then, here's the special thing. From the Grignard, we make a carbon-carbon single bond. Something very special, very rare, very important, which is why Victor Grignard won the Nobel Prize. And this becomes an alcohol. So start with a ketone or aldehyde. What's attached to it stays attached to it. The Grignard forms this carbon-carbon single bond and opens up the aldehyde or ketone to this alcohol. Let's have some fun. Oh, one other thing, the special first Monday of October gift to you, a little gift. This reaction, the actual Grignard reaction, I will never put as a synthesis problem on a test. All right, let's have some fun. And here's the fun. And the question is, give the organic product or products for the following reaction. And while you're doing that, writing it down, I'm going to sneak in some water. All right, now let's look at what's different. Ooh, oxygen double bond to carbon. It's got a hydrogen here. That could have been our double prime or hydrogen. And it's got carbons here, R prime. Then on top of the arrow, what's different? Carbon, ooh, magnesium chloride. That's the Grignard reagent. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon, carbon double bonds oxygen. What's attached to that are prime and our double prime or hydrogen will still be attached to that. The carbonyl opens up to an alcohol, and from the Grignard, we make that very special, very rare thing, a carbon-carbon single bond. And that's what the importance of this reaction. Everybody agreed to give Victor Grignard the Nobel Prize. Well, I don't know about everybody, but he won it. So let's keep our eye on the carbonyl carbon. Our double prime, which could be hydrogen, is. The other carbons are prime. From the Grignard, this is our double prime. So I'm going to start with what was the carbonyl carbon, this carbon right here. What's attached to it? Hydrogen. That's my R double prime, my R prime, 2 carbons. And remember, there's always 4 bonds to carbon. Then I'll have my alcohol, and the carbon with the Grignard will be the carbon in R triple prime bonded to this carbon with the hydroxyl group. And in one simple step, actually 2, but you run this in the same vessel when you make it, so it seems like one reaction. Put in the Grignard, let it react an hour or 2. Second step, add the acid and water, work it up, and you've made a new product. And notice we've made a much bigger molecule than what we started with. And that's the beauty of the Grignard reaction, because with that reagent, you can form a carbon-carbon single bond. Everybody got that copy down? Well, in that case, your turn. What would be the product or product for the following reaction? 3 points each. I hope you had a nice time since we last met. I started doing all my fall cleaning before the winter hits. Yesterday, I have in my house, I have this in my in my hallway and kitchen and dining room. I have this beautiful parquet floor that's really, you have to be careful treating it, taking care of it. And yesterday I washed it, the special way you do that. And today I'll put, they say wax, but it's really a polymer on it. So it'll be nice and shiny and pretty. And I've been doing that for many years now. And it always makes me happy when I'm done. All right, looks like almost everybody's done, but please be patient and let's give everybody time to finish. All right, my turn. I get to have some fun. Now, look for what's different, what's not carbon, what's not hydrogen. Should get your attention like this. Ooh, I snuck that in again. And, oh, oxygen double bond to this carbon. Carbonyl. It's got carbons here, carbons here. It's a ketone. It could have been an aldehyde. It's not. And then, ooh, I've got two steps here. First step, what's different here? Carbon, magnesium halide, that's a Grignard. And remember, X can be chlorine, bromine, or iodine. Second step, acid and water. And remember, this attacks this and forms an alcohol. Keep your eye on the carbonyl carbon, carbon double bond to oxygen. That's where all the fun is. What's attached to it? Our prime, our double prime, or hydrogen is still attached. This opens up to an alcohol. And then we do that special thing. We make to this carbon a carbon-carbon single bond from the Grignard. So here's my R prime, here's my R double prime, and here's my R triple prime. Have you missed that and it was too close? You can go back and watch the video and play it in slow motion. Keep your, oh, I'm not in slow motion. Anyways, keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it, our prime and our double prime are still attached. Our prime, our double prime. Why? Because you break carbon-carbon single bonds? No. By the way, I've been brainwashing you. Once I started doing that, students' grades really picked up nicely. This will have a hydroxyl group, and then my bond to the Grignard, our triple prime methyl, and that's how you do it. Oh, this was fun. I got to do another one. Let you have fun too. And there you go. Give the organic product or products for the following reaction. Boy, that looks like a fun reaction to do. Have you noticed time flies when you're having fun with Grignard reagents and reactions? They're so fun to do and so powerful. I see a couple thumbs, but we'll wait for everybody to finish. Am I nice or what? Everybody's finished. Now I can have fun. All right. How do you determine what will be the product or products of this reaction? You look for what's different, what's not carbon, what's not hydrogen. Ooh, an oxygen there. And that got my attention. This is a ketone. Here's a carbon here to the carbon, double bond oxygen, carbon here. They're connected together in a ring, but it's a cycloketone. Could have been an aldehyde, it's not. Ooh, look, carbon, magnesium chloride. That's a Grignard reagent, where X can be chlorine, which in this case it is, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon because that's where the fun is. What's attached to it, our prime and our double prime or hydrogen are still there. It opens up to an alcohol, and then we do that very special thing. We make a carbon-carbon single bond from the Grignard to this carbon that had the carbonyl carbon over here. So do you break carbon-carbon single bonds? No. Keep your eye on the carbonyl. That's this carbon. These carbons are still going to be there. So you're still going to have your ring that has the methyl group here too. This carbon is this carbon. You'll have a hydroxyl group. And what's my R triple prime? This isopropyl. Now the carbon here with the magnesium chloride will be the carbon in here bonded to this carbon. So that's the center of 3. And that's what you get. Now, here's the beauty. And I mean this in all sincerity. This is a beautiful reaction. The molecule I just made, if I ever needed to make that, I don't know how I could do it without the Grignard reagent. I'm sure there's a way, but it would be very complex and many steps. Here, I find this ketone, which you could probably buy. I make this Grignard from an alkyl halide, and boom, I'm done. 2 steps in the same reaction. You're done. And that's why it's so beautiful. And you've made a carbon-carbon single bond. That's also beautiful. Oh, I got to do another one. And I tell you how strong organic chemists are. We can bend arrows when we need more room, and I will. So, what would be the organic product or products for the following reaction? Your turn to enjoy this reaction. How many different synonyms can I come up with for fun? Thank you, Christiana. Thank you, Andrew. And we'll be patient. And thank you, Ignacio. See, I was patient. All right, my turn. Look for what's different, what's not carbon, what's not hydrogen. Should get your attention like this. They get your attention. And what do we have? Oh, we have an oxygen here bonded to double bond to carbonyl, to carbonyl. It's got carbons here are prime, and I could have carbons also here are double prime, or I could have a hydrogen, which I do. This is an aldehyde. Ooh, carbon, magnesium halide. This right here is a Grignard. And X can be chlorine, or in our case, bromine, or iodine. Second step, acid and water. This attacks this, opens it up, and you, after the second step, you keep your eye on the carbonyl carbon. What's attached to it stays attached to it. This opens up to an alcohol, and from the Grignard, you do that special thing. You make a carbon-carbon single bond. So here's my carbonyl. And what's attached to it, hydrogen and an isopropyl group. It's a long carbon-carbon single bond. Hold on 1 second. Then I have hydrogen. And then here is my Grignard. And do you break carbon-carbon single bonds? No. I have 4 carbons. Which carbon of the Grignard is bonded to the magnesium bromide? The N carbon. And that's the carbon that will be bonded to this carbon right here. And I know there are 4 bonds to carbon. And that's the molecule, the alcohol we've made. And notice I take a simple aldehyde, a simple Grignard, and I've made this very complex alcohol. And that's the beauty and the power of the Grignard reaction. Any questions? Remember this reaction, I will never give a synthesis problem on a test or on the final. Whoops, it's time to close all my Word documents. And open them up again. Got so many things running on this computer. between Zoom, my tablet, my mouse, and my webcam. For some reason, I overload something when it happens. All right, let's move on. All right, let's talk about hydrogenation of ketones and aldehydes. And if our double prime is a hydrogen, this is an aldehyde. If it's carbons, it's a ketone. If I take hydrogen gas and a catalyst, I will form an alcohol. And let me show you this on on the whiteboard. You know they named that after me. If you believe that, I got a bridge downtown Chicago. I'll sell you cheap too. But anyways, now a carbon-oxygen double bond is one pi bond and one sigma bond. You've heard that before, like a regular carbon-carbon double bond. And when I add hydrogen to that, guess what? I can break the pi bond, and each atom of the double bond gets a hydrogen. And this is a nice way of making alcohols from aldehydes and ketones. It's clean, it's easy, and it works. And I've used this reaction too. So let's take a look at this reaction. Oops. Just thinking of the last reaction. Don't need that. And the question would be, what's the organic product or products for the following reaction? And if we look at this molecule, what's different? What's not carbon? Anybody keeping a record how many times I've said that this semester? I think I'm going for the Guinness Book of World Record. What's not carbon? What's not hydrogen? Ooh, oxygen double bond to carbon. That's different. And I have a hydrogen there. That could be our double prime or hydrogen. Carbons here are prime. And we have, in this case, an aldehyde. Reacting with hydrogen, gas, H2, ooh, Ni. That's a nickel catalyst. Remember, the catalyst can be nickel, platinum, or palladium. In this case, it's nickel. And what happens? Remember, there's one pi bond and one sigma bond. Do you break the pi bond? Yes. I bet you thought I was going to say no, but you do break pi bonds. And each atom of the double bond, oxygen, carbon, get a hydrogen. What's attached to that carbon, our prime and our double prime, or hydrogen, stays attached. So here's this carbon. What's attached to it? Our double prime hydrogen, our prime two carbons still attached to it. I break the pi bond, and each atom of the double bond gets a hydrogen. Now, you can write it this way, which is fine on a test, or you could have also written it this way. These two are identical, just different ways of writing it. Notice this carbon right here has two hydrogens and a hydroxyl group OH. So that's how you do it. And it's a fun reaction. And Later on, when we get into carbohydrates, I'll show you how this reaction is used to make a very widely used ingredient in over-the-counter medications. So why are we learning these reactions? Because they're used in your everyday life. I did it again. After I do the Grignard, I keep on wanting to put a 1 down there for a 2-step reaction. This isn't. And here's your turn. What would be the organic product or product for the following reaction? Thank you, Andrew. We'll wait for everybody else to finish. Thank you, Christiana. And Ignacio's done, so I can get to work. And the question is, what's the product or products of the following reaction? And if we look, what's different, what's not carbon, what's not hydrogen, carbon, double bond to oxygen. It's got hydrogen on it. That could have been our double prime or hydrogen it is. And it's got carbons here. I'll call that R prime. This is an aldehyde. And when we react with hydrogen, what's platinum? It's a catalyst for hydrogenation. And you could have also palladium or nickel. Keep your eye on this carbonyl carbon. That's where all the fun is. What's attached to it? Our double prime or H. And our prime is still there. You break the pi bond, and each atom of this double bond, which is 1 pi bond, 1 sigma bond, gets a hydrogen. Well, here's my R prime. Here's my R double prime. Here's my carbonyl carbon. I'll draw that again. H, isopropyl. And then now I'll break the pi bond, and each atom of the double bond, carbon oxygen double bond, gets a hydrogen. I made that alcohol. And that's one way of writing it. Everybody check their answer. I will be patient while everybody's checking. All right, looks like everybody's done checking. Oh, let's do another one. Now, this reaction, I can give you a synthesis problem. What would I react with hydrogen and palladium to make that compound? 3 points each. Boy, I'm working you guys hard today, and gals also. Well, let me rephrase that. I'm working you students hard today. That way, I'm being politically correct, which is not a bad thing. I always try and treat everybody equally. And I do. Thank you, Christiana. And we'll wait for everybody else to finish. Ignacio's finished. We'll wait for everybody to finish. And Andrew's finished. So it's my turn. And if we look here, we look at what's different. What's not a carbon or hydrogen? Ooh, oxygen with a hydrogen on a carbon. That's an alcohol. And I have carbons here, carbons here. It could have been a hydrogen. And what do we react with hydrogen in a catalyst? Remember, the catalyst can be platinum, palladium, or in our case, well, it was palladium or nickel. We start with a carbonyl. And you break the pi bond. And each atom of the, I should have written it that way. I could have, because there wouldn't have been four. You get this alcohol. Well, this carbon is this carbon. This is our double prime. I can call this our prime. And notice they're connected together in a ring. Do you break carbon-carbon single bonds? No. So I'm still going to have my ring. And I'm still going to have this ethyl group there. The carbon here is this carbon will now be this carbon, which means it's double bonded to an oxygen. And that's how you do it. And I'll give you all time to check your answer. I'll sneak some water in. Boy, these ketone and aldehyde reactions are thirsty work. All right. Now, the following, what I'm going to do not write down unless you want to. Let's look at the following reaction. Everybody see it on your screen now? If I take this molecule, notice I have not one, but two functional groups, aldehyde and a double bond, and react it with nickel and hydrogen. And what will happen? Well, one reaction would be this, and you break the pi bond. And each atom of the double bond, carbon oxygen, gets a hydrogen. But wait, we also have a double bond. And you learned double bond, hydrogen, and a catalyst. You break the pi bond. And each atom gets a hydrogen. Now, if we wanted to keep the double bond and convert this into an alcohol, what are we going to get? A mess. What do you mean a mess? Well, this could happen. Which is what we want. This could be the only thing that is hydrogenated, which is what we don't want. And the third product, 1, 2, 3, we could also get this. Again, you don't have to copy this down. So 2 of the 3 things could get, I don't want. So what do? You're going to have to wait because it's time for a break and it's time for a cliffhanger from Dr. White. You're going to have to come back after the break to find out how do I turn this aldehyde to this alcohol without getting this to happen. And you'll just have to wait 5 minutes. Am I cruel or what? Anyways, I'm going to go stretch. I'll see you in 5 minutes and we'll continue on. I'm back. I went and checked my mail and I got stuff, including my water bill. How much fun can you have? All right, hang in there while I look at something important. I want to look up something. All right, thank you for hanging in. All right, I left you with a cliffhanger. How do you solve this problem? Because hydrogenation will attack a pi bond. And this molecule I showed you, there are two of them. Well, turns out this was solved. And this was solved by the great organic chemist, Herbert Brown. And sometimes you'll hear him called H.C. Brown, and it's Dr. Brown. Now, it's interesting, the same thing happened to my grandparents. Dr. Brown's parents, actually, he was born in Ukraine. And he's a Ukrainian Jewish immigrant. And when he came to Chicago, they changed his name, or his parents did, to Brown. My grandparents, my father's father came from Russia, and he did the same thing, changed it to last name White. But anyways, H.C. Brown, Dr. Brown, worked at Purdue University. And he's considered a great organometallic, it's called, chemist. And he won the Nobel Prize in 1979. He died in 2004, unfortunately. But anyways, he was 89, but still. What did he do? Well, during World War II, there was a great increase in the knowledge of organic chemistry. Why? Because the American British were trying to make compounds for molecules for the war effort that they were cut off from by the Germans and Japanese. And H.C. Brown was part of that effort. And his two molecules he discovered or invented, I'll only teach you one, is called lithium aluminum hydride. Lithium aluminum hydride, also known as LiAlH4, and that's lithium aluminum hydride. Now, think of this molecule, lithium aluminum hydride, like H+. It's similar to the Grignard if you thought of the Grignard as R-, which I didn't mention earlier. And this will attack with the H-. And I put the quotes there because it's like that. And then once again, second step, acid and water. Now, the interesting thing about lithium aluminum hydride, that will only attack carbonyls, double bonds. It will not react with carbon-carbon double bonds. And that's the beauty of this reaction. So let's take a look at it. And in my research at Michigan State for my PhD, I did use this a number of times, this reagent. Keep your eye on the carbonyl carbon, and it does the same thing as hydrogenation. But the beauty of this is it won't touch a carbon-carbon double bond. All right, so let's look at this reaction. I assume everybody can see it because I see someone furiously writing it down. And more than someone, a couple of you. All right, now what's different? What's not carbon? What's not hydrogen? Oxygen double bond to carbon. We have a ketone. Could have been an aldehyde, but it's a ketone. This is my R prime. This is my, and that's a 3, R double prime. And what are we reacting with? LiAlH4. That's lithium aluminum hydride. Second step acid and water. And remember, it's like H minus here. And what happens is you break the pi bond. The second step puts the H on the oxygen, for those who like mechanisms. And you break the pi bond of the ketone or aldehyde. And whatever is attached to the carbonyl carbon is still there. So here's my carbonyl carbon. It's going to be something different. What's attached to it? Methyl and ethyl, R prime. And then I break the pi bond. And each carbon gets each atom gets a hydrogen. And that's how you do it. Now, something I just had a realization. How come at times my online Zoom lectures seem to cover less than if I were face to face? And it dawned on me, if I were in a classroom, this would stay on a whiteboard and I could start writing something else. And for those who haven't finished could still look at it. But when I go like this, you can't. So that's why I slowed down, which I think is a good thing. But we're covering everything we should. All right, your turn. Let me draw this better. There you go. Excuse me. I'm getting all choked up over this stuff. That was bad. And while you're doing that, thank you, Christiana. While you're doing that, don't forget, this is the second week of my new office hours. Remember, my new office hours, same Zoom login, but different time and day, are now Tuesday and Wednesday from 6 to 7:15. Same Zoom login, same Dr. White. Better drink something. Got a tickle in my throat. Feels like I got a feather in there, even though I've never swallowed a feather. Wonder where that expression came from. And please be patient. I try and give everybody time to finish. All right, let's move on. What's different? What's not carbon? What's not hydrogen? Oh, look, oxygen double bond to carbon. I've got carbons here, excuse me again, R prime, and I could have carbons here, R double prime, but it could also be a hydrogen, which it is. This is an aldehyde. And here, R prime, R double prime. What am I reacting this with? Lithium aluminum hydride. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to that? R prime and R double prime are still there because you don't break carbon-carbon single bonds. Now here I have a pi bond and that I can break. And this reagent, you break the pi bond and each atom of the double bond gets a hydrogen. So I'll write this carbon, what's attached to it, R prime, 2 carbons, R double prime, hydrogen. I'll break the pi bond, and each atom of the carbon-oxygen double bond gets a hydrogen. And that's how it works. And it works quite well. Oh, let's try another one. This reaction, I can put on a synthesis problem. Test number 2 will have 4 synthesis problems over any of the reactions I've covered that I say I can do a synthesis. The reactions with hemiacetal, hemiketal, acetal, ketal, I won't. And the actual Grignard reaction to react the reagent, I won't. But this one I can. What would I react with lithium aluminum hydride, acid, and water to make that molecule? I've been secretly training your minds to know how to do organic chemistry. And it's working. Thank you, Andrew. I see somebody else's thumb. Thank you. I see everybody's thumb. Here's my thumb. I've got 2 of them. Oh, that was awful. I apologize. No, I don't. Those things just slip out of my brain. I have no control over it. All right, let's do this. How do we determine what do you react with lithium aluminum hydride, second step acid and water? We look at the product. What's different? What's not carbon? What's not hydrogen? Should get your attention like that. And the answer is, ooh, oxygen with a hydrogen on a carbon. And alcohol. And this carbon here, as carbons here and here, I'll call R prime and our double prime. Our double prime could have been a hydrogen, but it's not. And what do we react first step with lithium aluminum hydride, LiAlH4, second step acid and water? And the answer is a ketone, or R prime can be a hydrogen and aldehyde. Well, here's my carbon, this carbon. It's got carbons here and here. They're connected together in a ring. Do you break carbon-carbon single bonds? No. So they're still going to be attached to that carbon. And they're still going to have these two methyl groups. This carbon is this carbon, which is double bonded to an oxygen, which is this carbon with the hydroxyl group, which will be now that carbon. And that's how you do it. All right, looks like everybody's copied down. In case you were wondering, and I didn't want you to leave my class wondering, how would I do this reaction? Take this molecule and just make this alone? And this will never be on a test or a final, but use lithium aluminum hydride, acid and water, second step. Lithium aluminum hydride does not react with a carbon-carbon double bond, because this has got electrons here. Remember, this is slightly positive and negative, and it's a nucleophile, and that's why that hydrogen attacks the carbon there. I didn't want you going home or leaving my class wondering, well, how would I actually do that? I'll never do that on test, but that's how you do that. Wait a second. Oh no, I think you guys need a pick-me-up, something to pick you up. So guess what time it is? It's time to play that fun game. Let me get some room here. It's time to play that fun game, circle and name the functional groups. Two points each. How do you play that fun game? Circle and name the functional group, 2 points each. You look at the following molecules and circle and name the functional group. I am not asking for what's the IUPAC name. Just circle and name the functional group. Two points each. And And there you go, A, B, C, D, and E. Dr. White knows his alphabet. My first grade teacher would be smiling now. That's, I think, when we learned the alphabet. So you're playing the fun game, circle and name the functional group, 2 points each. Have fun, because it's a fun game. Can I say the word fun anymore? Of course. Have fun. Are we having fun? Let me know when you're done or when you're finished, or would like me to get going because you don't know all the answers. I see one person done. I see two. And I'll be patient and let everybody have time to figure it out and finish. Because I don't want to cut into your fun. See, I said I could say it a lot of times, and I do. Again, please be patient. I'm trying to give everybody time to finish. And if you finish early and looking for something to do, try this. One finger goes forward, the other goes backwards. Do it at the same time. Don't do this while you're driving. And if you want to master that, do it with your thumbs. All right, I think everybody's done. So I better get to work. And we're playing that fun game, circle and name the functional group, 2 points each. How do you play that fun game? You look for what's different, what's not carbon, what's not hydrogen, should get your attention. Ooh, OH on a carbon. And I'm going to write this down. You don't have to, but that's an alcohol. Let's look at B. Ooh, what's different? Here's an oxygen, and it's got carbons here and here. And what's that? You don't have to write what I'm writing down here, but this is called an ether. R-O-R prime. Carbons, oxygen, carbon. Let's move on to C. What's the, an oxygen here bonds to this carbon with hydrogen carbons, and that's this. If you circle an extra hydrogen or carbon, don't worry about it, and that's an aldehyde. Now here in D, what's different? Another oxygen, and it's bonded to this carbon, double bonded with carbons here and here. And what do we have? And here R and R prime are connected together in the ring. This is a ketone. Ketone. That oxygen should be in the circle. Hold on. And if you're missing a carbon, don't worry, I don't. I'm the one grading it. And that's a ketone. And finally, if we look at E, I've thrown everything in but the kitchen sink. I don't want to lose my sink. Oh, that was bad. And look for what's different. Oxygen here, carbon here, here. That's an ether. Ooh, another oxygen. Bond to carbon with the hydrogen carbons. That's an aldehyde. Am I done? No. I've got another oxygen up here with the hydrogen carbons. What's this? Alcohol. Now, where I'm showing like ROH or the you don't have to do that. All you have to do is circle and name the functional group. Am I done? No, one more oxygen here. Find a carbon there with carbons here and here. They're connected together. This is a ketone. And that's how you play that fun game, circle and name the functional group, 2 points each. Now, on a more serious note, if you don't know how to identify a functional group, how are you going to name it? How are you going to know what reactions occur with it? You don't. So I would hope you all practice that fun game, circle and name the functional group, 2 points each. We'll do it again next week, probably. It was such a fun game. All right, I forgot to pull it. Everybody see on your screen oxidation of carbonyl compound? Put a big X through it. I'm going to cover this next chapter, not this chapter. Oh, wait, and you'll see it makes more sense. We get into carboxylic acids and their derivatives next chapter. So this will not be on test number 2. And you all have each other as witnesses. I said that. This will not be on test number 2. We'll cover it next chapter, which means let's move on. All right. Next couple slides, I'm turning, will this be on a test? Click to the off position, but it will be good background information for the reaction that I will turn on the switch. It will be on the test number 2. Now, if it looks like I'm having way too much fun, I will be, because it's an area I'm an expert in, and it's an area I did my PhD thesis in. a specialized part of it. All right, now in organic chemistry, there's something called a tautomerism. And tautomerism is when you move electrons and an atom, usually a hydrogen. Let's hold on. I've never done this before. Looks like it's not going to want, let me. In which protons are transferred from one area to another, and also electrons too. They don't talk about this. But anyways, let's get back to our example. And we're going to talk about keto enol tautomerism. And again, switches off for the slide. This is an aldehydes and ketones may exist in an equilibrium. This is not a resonance form. It's an equilibrium of two forms called the keto and enol form. See board, I better get to work. Now, as you know, the carbon double bond to oxygen is the carbonyl carbon. Now, there's terminology I'm going to use I will never ask on a test. The carbon bonded to the carbonyl carbon is called the alpha carbon. And they're fun too. And for the enol keto tautomerism, it's an equilibrium. Again, this won't be on a test. Notice this bond came here and the hydrogen went there. Now, this is called the keto form because it could be a ketone or aldehyde. What do we call the ending for a double bond? ENE. What do we call the ending for an alcohol? OL. Put them together and you get enol. Isn't that cute? I think so. And this is an equilibrium that exists in ketones and aldehydes. Quite an important equilibrium. Now, it turns out the alpha carbon has hydrogens, which are called the alpha hydrogens in a carbonyl carbon. And they're more acidic than a hydrogen and an alkane. And this is due to the resonance stabilization of what's called the enolate anion. Again, switches off, and now Dr. White's really having a good time because I did my research on very specialized enolate anions, which I'm a world authority on. Alpha carbon, these hydrogens are acidic, meaning they can easily be pulled off. Remember, switches off. To form, this is called the enolate anion. If it looks like I'm smiling, I am. And there's a resonance form. And now we use a double head arrow. So I can move the electrons here and here. To form the other resonance form of the enolate anion. And the more resonance forms you can form of something, the more stable it is. And that makes with a base, You can make an enolate anion, and turns out enolate anions really like to react. In fact, I'm going to show off now. Most organic chemists, what I'm about to say, wouldn't even understand what I'm saying because it's very specialized. But I did my PhD thesis dealing with cross-conjugated, kinetically favored enolate anions. Oh, I just had a good memory. Well, it got me my PhD, that research. Again, very specialized, but dealing with fun. With enolate anions, you can make carbon-carbon single bonds, which is very rare, very special, and very good. So the alpha hydrogen on a carbonyl compound, ketone or aldehyde, is more acidic, and I can form the enolate anion. Well, I showed you that. So, all right, switches on. Click. Let's talk about the aldol condensation. This is a reaction in which you use enolate anions. The one thing I should have put down here, which I didn't, is usually just done water or ethanol. Now, I'm going to do a special gift for you. And let me rewrite this reaction on the whiteboard. And my special gift to you is, first of all, we'll only teach you for aldehydes. It also can be done with ketones. And second, I don't have to, but I will write the reaction like this. And I'll stick to potassium hydroxide. There are other bases you can use. And what happens is you'll take a hydrogen off here with the base to form the enolate anion. It's a nucleophile. It attacks the other aldehyde carbonyl. And first of all, you'll form from this first aldehyde this enolate anion. It will attack bond to the other aldehyde here and open it up to an alcohol. And then what's attached to this second one here is still attached to it. And we made this carbon-carbon single bond, which is always very special, very rare, and oh, so very good. Now, why is this called the aldol condensation? Well, I've got an aldehyde here, an alcohol here, and you put those two together, Al, OL for the alcohol. And condensation, you condense, bring two things together to make one molecule. And this is the aldol condensation. If I sound like I'm having a good time, I am. If it looks like I'm running out of space here, I am. So I'll go like this. And I'll do this one. We look at this, what do we have? Remember, play that fun game, circle name the functional group, 2 points each. Well, I've got an aldehyde. I've got the same aldehyde. I'm reacting with sodium hydroxide and water, a base. And this is the aldol condensation. And for my PhD thesis, I ran this reaction to make certain molecules I needed. Remember, the alpha carbon, the base pulls off one hydrogen, so I'll do that. And then this attacks the other carbonyl carbon to form a carbon-carbon single bond. And what was attached to this carbon here, H, CH2, R, is still attached. Now, if I look up here, there are two ways I can do this. I can say this is R and this is R. Therefore, I'll get the molecule down here. Or another way of thinking of it, alpha carbon, pull off a hydrogen, this attacks that. When I pull off that hydrogen, I'll lose a hydrogen there. So instead of H2, it's H. And then this will bond to the other carbonyl. What's attached to that? Hydrogen, CH2, and CH3. So either way you want to do it, that's how you do it. My gift to you is I will never give a synthesis problem with this reaction. My gift to you is I'll never do a synthesis problem with this reaction. And I'll take a break while you write down this complex reaction. And give me a thumbs up when you're through copying. Oh, tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. All right, everybody done copying it? If I look at the clock, instead of rushing through one, I'm going to do something which I can do. I'm going to end a whole 3 minutes early. Don't tell the dean. Actually, you can, because technically with a net course like this, I don't have to give these lectures. I do because I want you to do well, but I don't. All I have to do is show up a couple hours a week, like my office hours beyond that, and help you out if you have any question. Well, that's why I do lectures instead of just, I don't know, I think cheating you out of time you should get. I don't. If I talk enough time, we won't have 3 minutes, so I'll be done. But anyways, listen carefully. This is the last reaction, and I'll go over it again on Wednesday. And then you should be doing the problem set for ketones and aldehydes, because next Monday, a week from today, I will go through that. Also, a week from today, next Monday, I will go through and do the review for the next test, which is test number 2. On Wednesday, we're going to go through this. Remember, because I got ahead of myself by a week, this Wednesday, we won't have a lab to do. I like that. No lab. I could have said no lab. That will confuse everybody, but no lab. But we still will have a Zoom meeting. Make sure you hand the lab that we did last week this Wednesday. And with that, I'm going to call it a day. Actually, it's only 2 minutes or so less than what you normally would have gotten. And with that, I will say, Gang gesund, goodbye. Stole that from Granny. In case you forgot, Gang gesund means go in health in Yiddish, something my grandmother used to always say to me, my sisters, and my parents when we'd leave after visiting her. Great lady. One of the finest people I ever met in my life. And with that, I'll say once again, Gehen gesund. See you on Wednesday.